So the last thing we want to talk about in this Rivets welding and bonding series is to talk about bonding. And bonding includes brazing and soldering. Brazing and soldering are bonding processes, and bonding is a process that occurs below the melt temperature for the workpiece. So it occurs below the melt temperature of the workpiece. Typically, depending on the source that you look at, but the workpieces are heated. Work pieces are heated to above or about 800 degrees or more Fahrenheit. That's about 430 or 127 degrees Celsius. For brazing, okay, and soldering is done when the workpiece is usually below 800 degrees Fahrenheit. So in bonding, specifically brazing, the materials are often powders or powders and something that helps them stick to the surface, and they're often copper, silver, or nickel. So materials that melt at lower temperatures than the workpiece. Flux is required, and it's required if you're not in a vacuum. If you're not in a vacuum or in a shielded gas. And the role of the flux is to prevent oxide layers and actually remove oxide layers so that the bond is better, for a better bond. So as with welding, brazing, there's an awful lot of American Weld Society classifications for different materials. You can see they're predominantly silver, copper, zinc, aluminum, and nickel, and then there's other materials. So these are the American Welding Society classification. These are often in powders, and these are the different compositions, and then you can look at what these are used for. If you look in the machinery's handbook, you can also see, in addition to the many different types of materials and the flux and temperatures that you can use, you can also get a feel for the different brazing symbols if you were to call them out in a drawing. Okay, and you can see here how that's specified and kind of how the brazing looks in terms of a powder that might be applied, or some slurry of brazing compound between joints, and then you would heat up the workpieces, and the workpieces would cause the brazing material to flow, and it would be cooled, and then you'd have a nice brazing joint. If you look at these parts, you'll see there's a strong similarity between brazing and soldering of circuit components. But in soldering at these lower temperatures, it's primarily done for electrical components. For more machine applications, the brazings, which are done at higher temperatures, usually have higher strength. So something to consider. If you have an application that requires that requires materials to be bonded to one another, brazing may be an option for you to consider. Another thing to consider, which is being more and more widely used, is adhesives. In fact, even in automobile manufacturing and assembly, adhesives are used to hold body parts together, and lots of applications that you might not think. There's some very, very powerful adhesives that are available. For example, some epoxies, and an adhesive is just another form of fastening or joining two things. And this is the last one that we're going to talk about in this class. But we have screws, bolts, welds, bonding, which includes brazing and soldering, and adhesives. Some adhesives, such as thermoset high strength epoxies, so a thermoset epoxy, they'll typically have a strength between 25 to 40 megapascals, but they even have strengths up to 70 megapascals, which may be suitable for some applications. A few points that I want to make is the use of adhesives can reduce costs. Okay, I know that we often want to screw and bolt everything together as mechanical engineers, but adhesives can reduce costs, which maximizes profit, which means there's more money to pay your salary. Usually adhesives are not conductive, so they're usually not very electrically conductive or thermally conductive. And when we make statements like this, there's almost always a caveat, because there's always somebody that has created a specialty material that will do that'll violate this generalization. However, there's usually a cost associated with it. So in general, they're not conductive either thermally or electrically. Usually they are compliant in the sense that they are less stiff than a bolt or a screw. So adhesives are usually more compliant. Okay, even though you might think of an epoxy as being hard, it's a lot less hard than when compared to a bolt. They usually can't withstand high temp. Okay, so they'll break down or melt or burn at high temps. They are usually cheaper than other fastener types, and can often be automated. Often be automated. So those are some points we want to make about adhesives. So these are some generalizations for you to keep in mind. Again, we're trying to solve the problem of joining things with the screws, bolts, welds, and bonds, and that concludes this video series on welding, rivets, and bonding processes.